I was just kidding. I still have 10 more minutes. Let's finish number 5 for this video, exclusively for this video. Everything about part 2 is going to be for number 5 only. Nothing more, nothing less. I hope nothing less. So, let's draw the illustration. So this is, it's 2. Okay, this is gonna be the object. So the end block, the 100 end block is placed on a 30-degree inclined plane. The weight is said to be 100 newtons. This is Fa, again, this is Fn, this is frictional force, this is F perpendicular, this is weight, this is force parallel. Now, the coefficient of sliding friction between the block and the plane is said to be 0.25 or 0.250. Now, we have to calculate for the velocity and the distance of the block after 3 seconds. Now, I don't remember what this topic is, but it's something about like a falling object. We have case 1, case 2, case 3. It's going to be, our scenario is going to be similar with that, in the sense that we'll need to look for these 5 values. So gravity, as we know it, it's always going to be 9.8 meters per second squared. Time final, or yeah, just the time, that's going to be 3 seconds. Distance is missing. That's what we're looking for. Calculate the distance as well as the velocity after 3 seconds. So VF is missing. Now, what is VI? That is supposed to be equal to 0 meters per second. Everything starts, as it starts to fall down, is always going to be 0 meters per second, the initial velocity. So, what do? Now we have all the given values and we've identified what's missing. We then have to look for the acceleration. So, hang on, sorry. I don't think we need the gravitational acceleration. We need the acceleration, like the plane acceleration. Hold me to my word until later. Unless it's unless we have to revert it back to what I said earlier. So Fx can be written as ma from the formula F is equal to ma. Now Fa can be written as force parallel. Ff can be written as un from the formula F is equal to un. Now, mass is said to be, well, we don't have the mass, but we can calculate for it. W is equal to mg, m is equal to w over g, m is equal to the weight, which is 100 newtons, g is 9.8 meters per second squared. Now, 100 over 9.8, that is equal to 10.20408 kilograms. Now, we have 10.20408 kilograms times acceleration is equal to force parallel, that is equal to W cosine theta. Is it? Parallel sine, joke lang. This is sine theta. And then frictional coefficient is equal to what? 0.250. And the normal force is missing. Is it? Well, normal force, provided that even in the event that the object is moving, summation of Fx is still 0n. That also goes for the summation of Fy. So, we all know that involving Fn, 0 newtons is equal to Fn minus force perpendicular. Therefore, force perpendicular is equal to Fn. We have to know this. So, from there, we can write Fn in the way that we write the formula for first perpendicular, which is W cosine theta. Now, 10.20408 kilograms times acceleration is equal to, what's the weight? 100 newtons. So 100 newtons sine, what's the angle? 30 degrees. Minus 0.250 times 100 newtons cosine 30 degrees. Now, this is going to be equal to 50 newtons, this one. And this one will be equal to 21.65064 newtons. And then here, it's all the same. Now, we have 28.34936 newtons after subtracting, and then below we have the same thing. Now, newtons over kilograms, that's going to be equal to the value or the unit of acceleration, which is meters per second squared. 2.77824 meters per second squared, that is the value for acceleration. Now, from there, we have to look for distance. So distance, again, is one of the missing values that we have to look for. D is equal to VIT plus AT raised to 2 over 2. I've already introduced this formula in my previous videos, so I think it's easy to follow. VI is 0 meters per second. Time, so this will be 0 later afterwards. A is 2.77824 meters per second squared. And then time is said to be 3 seconds earlier, based on what was read earlier. So, from here, this entire thing is said to be equal to 12.50208 meters. So, we found one of the missing values. Now we have to look for VF. Looking for VF this time is easy. We can use this formula. Acceleration is equal to VF minus VI over T. So acceleration is so we'll just have to transpose. We have something like this. AT plus VI is equal to VF. VF is equal to, what's the acceleration again? 2.77824 meters per second squared. And then the time is 3 seconds. Plus VI, which is 0. So essentially, it's just this that we have to multiply in order to find VF. VF is equal to 8.33472 meters per second. So that's it for this video. Thanks for watching.